Welcome to Gradcast, the official podcast of the Society of Graduate Students at the University of Western Ontario.
Howdy there, everyone, and welcome to Gradcast, the official radio show of the Society of Graduate Students here at the University of Western Ontario, broadcasting to you live on 94.9 FM. I am your host, Joseph Donohue. Beside me, the lesser-known Viking, Eric the Green.
How's it going, everybody?
And behind the board, as usual, we got Tristan Johnston. How you doing, bud?
Howdy, howdy.
Good. Okay, today we got a friend of mine coming in from the Department of Chemical Engineering. We have Mr. Ben Lee. How you doing, my friend?
Good.
Good. Okay, so we got you on here to talk a little bit about your research. So why don't you tell the folks here what exactly you're doing here at the university?
I'm studying about mainly fluidization. My topic is effect of fluidization velocity on jet bed interactions. So the project is from fluid coking. It's what we do to refine heavy oils.
Okay, so why don't you walk us through here on how we actually get the petroleum from the ground into something usable for our cars and things like this?
I'm not familiar with how we recover the oil from the ground, but as for refining, I know how do we make petroleum into gasoline or diesel? In refineries, the first step is always distillation. That's not it's without chemical reaction. So it's we divide the petroleum, the crude oil, into different classifications. So the boiling point into gasoline, diesel, and heavy oil. For heavy oil, we use catalyst cracking or coking craft to deal with that.
Okay, so coking is basically to try and get some of this hydrogen off of that carbon, to take those big, heavy chunks of oil and essentially get it into those smaller pieces that you need to be going in through the rest of your process. So the coking process is kind of a major part of this because a lot of these oils that are coming out are very heavy. Mm-hmm. So what is the typical kind of coking mechanism that we have going on, the coking technology that we're using right now?
Mainly there are two kinds of craft about coking. One is called delayed coking. The other one is fluidized coking. So it's the first one is which I've been studying for 2 years in China. It's using cracking at high temperature and no catalyst. So there are two processes that goes on in the bed. The first one is cracking, which means the long chains of in the oil, in the heavy oil, will break into smaller chains, and we'll get C1 to C4, which is gas, and gasoline, diesel, and at the same time we'll get coke, because there are too many carbons in the residue oil, so we have to get the coke out to balance the hydrogen to carbon ratio.
Why is it important to do that?
Because the lighter oils like gasoline and gas, they have higher hydrogen to carbon oil ratio. So if we want to get that, we have to get the carbon out.
Okay.
Right? Yeah.
So that's delayed coking, right?
Yeah, delayed coking.
Okay, so what's the difference between delayed coking and what you're working on, this fluidized coking?
Yeah. For delayed coking, there's a problem because the oil goes through a long string of pipe, and after months of running, there will be coke sticking into the walls of the pipes. So you have to clean it, right? But in fluidized bath, there is coke in there, and you keep it running, and you can clean in the meantime all the cokes, and you burn the cokes to provide heat into a reactor. So that's what makes it better.
If I can just jump in here and just ask a clarifying question. So the whole process of coking is to separate heavy oil into its smaller strains, diesel, petroleum, stuff like that. Am I correct in saying that?
Yep. Good.
Okay.
Yep, good. You're following along.
All right,
good.
good.
That's
Good. I'm learning. So my question is, you're saying that the byproduct of this process is coke, and you have to get that out. Now, when I hear coke, I'm thinking Coca-Cola. So
right,
if
good.
somebody could just maybe clarify for me what this actually is.
I thought that was the process of Coca-Cola, no?
We're getting sued here.
Yeah,
it's a new type of
We're
reactor.
getting shut down. This is our last show.
Coke, you can you've seen coal, right? It's similar to that, something like that. You can use it to deal with like aluminum, iron, or something like that.
Yeah, because coke is basically carbon. Like it's actually the leftover carbon that's kind of like condensed down into like this kind of very much looking like coal, which is essentially carbon, right? So really what you do with that coke is you can use it, as he was saying, in some type of generators that's actually providing the heat to that reactor, because you know you've got a lot of waste heat. We need a lot of heat that's coming into that system, so you can take that product out and actually use it to actually heat the system.
Oh, so it's almost like a very useful byproduct of the process itself.
Kind of, because it's also hazardous to the operation. So in fluidized coking, I imagine that what you're actually trying to do is trying to minimize the amount of coke being formed. Is that correct?
Yeah.
Okay, so how is the fluidized bed? Like I use a fluidized bed, but I'm using it to treat water, so this is polar opposites, literally. So I'm interested.
Oil and water.
Oh, they're not mixing.
Drum set in here.
So yeah, I guess my question is really like, how are you using the fluidized bed? Like, is it a liquid fluidized bed or is it gas solid fluidized bed? How is the liquid being changed into these byproducts?
Like in industry, for the fluid cokers, there'll be steam in there, which is like gas, the gas phase, and the feedstock. That's the residue oil, which is liquid, and there's coke, the solids. So it's like three-phase.
Oh, that's a hard one. That's a tough one.
Yeah.
Yeah, three-phase is very difficult to model and even to deal with in any kind of analysis. So that's very difficult. So on your particles inside the bed, your solid phase, is that strictly your coke, or is that going to be things like a catalyst to help you kind of reduce the temperature?
That's the coke.
Okay.
There's no catalyst.
No
in
catalyst
the
at all.
reactor. Yeah.
Okay. Yeah. So you're working right now at ICFAR.
Yeah.
Okay. Can you tell us a little bit about what ICFAR is and what you're doing there?
Yeah, ICFAR is Institute for Chemicals and Fuels from Alternative Resources. Like my supervisors, they are like devoted to resolving the problems about upgrading the heavy oil, like fluid coking, and use biodiesels to make like new energy for us.
Okay.
Yeah.
If I'd be remiss. I think that a lot of people out there listening would be disappointed if I didn't bring up a little bit of question. So as like we try to transition off of a carbon-based economy, these technologies you're developing, is there any way we could like use them to develop something like I don't know, something that either captures carbon or is carbon neutral or something like that? Maybe I'm stepped out of bounds.
No. I think that's a fair question. Okay, so I guess another point though would be like these heavy oils. Could they be produced from biofuels? Could you use like a biofuel heavy oil in this fluid coker?
If we like want to make something from the biodiesel, like or biomass, we wouldn't like want to make heavy oil because that's making it more like complex.
Okay.
Right. So we want to like make it into gasoline or something directly.
Okay. So then another part of that then would be, is the carbon that you're capturing as this coke, is that actually making it reduction in the CO2 emissions of the plant?
That I don't know, but like I know in Canada for the coke, they just bury it underground.
Okay. So that's carbon capture, quite literally.
Yeah. Sounds good to me.
He's okay with it. This is good news.
I think that was sarcasm. I just wanted to ask you a quick question, more on a personal level. When you heard about the ICFAR, you were studying at the China University of Petroleum, correct?
Yeah.
So what was it about ICFAR that made you want to actually leave your studies there and come to Canada?
Because like I've been in a program, master's program in China, mainly studying about delayed coking. But like since delayed coking is like not so good as fluid coking, you know, I want to learn something more that is like is more promising in the future, right? But like in China, there's no fluid cokers because like I don't know, because the patent belongs to ExxonMobil, the American company, so it's too expensive for the Chinese companies to buy them. So I came here to study more.
So is fluid coking more of a, well, I'm going to assume that it's a more modern idea than the, what was the first one called? I'm sorry.
Delayed coking.
Than delayed coking. Yeah. So where can you take it, do you think, like where can it go in the future to make the process even better?
That is a tough question.
It's what
He's
I do.
a hard-hitting journalist.
It's what I do.
I don't. There are many because this craft is already very mature now. So we're doing kind of things to make it a little bit more better. Because in industry, 1% more gasoline will make a huge difference, right?
Absolutely.
So it's not like you can jump in 10%, right? For what I'm doing now, I was gonna investigate about the velocity in the bed. So if we put more steam, for example, that's gas phase in the fluidized bed. If we put more steam at in a certain time, so the velocity will be higher, and the hydrodynamics will be interfered in a bed. So we'll see what's the difference after that.
Okay, and what would that translate into the process? Having that piece of knowledge, how would that help somebody operate these fluid cokers better?
Sorry, can you explain that?
Yeah, so basically now that we know that we're looking at this coke and it's coming through and we're trying to understand the hydrodynamics going on, and we're looking at the velocity of the solid phase with the gas phase moving through, what would that help an operator who's using one of these fluid cokers? How would it help them to either reduce the amount of coke being formed or even to increase the production of the gasoline?
That has something to do with the agglomerates.
Okay.
It's because the feedstock, the residue oil is injected into the bed through a nozzle. So if the bed velocity is higher when we inject the residue oil into the bed, there will be less, there could be, that's what I want to see in the future, there could be less agglomerates. If we have more agglomerates in the bed, we get more coke. So if we have less, so that's much better.
Yeah, exactly. Okay, very good. Okay, excellent. So what's something that you've learned throughout your research so far? Now, you've only been here for a year, if I'm not mistaken. Just about, not even.
8 months.
8 months,
Yeah.
okay.
Wow.
So what's something that you didn't know about fluid coking that you've now learned through your research?
Before coming here, I know nothing about fluidization. So, but here, I would say generally, I've learned so much about, it's not just about fluidization, it's about how to do research. The first thing is to use the tools. As you have said, half of the engineering is about choosing the right tools, right? So I've learned a lot, and through some of my friends at postdocs in my lab, through my supervisors, they have thrown a lot of ideas to me, and I have to absorb them gradually. You know? And the other thing is that I have to, when I run my experiments, I have to make sure it's close. It cannot be the same as the practical conditions in industry, but I have to make it close so that they can use my results, right? That really makes sense.
So you're working more towards not just specifically research, but more industrial types of research.
Yeah, my projects are funded by Syncro,
Okay.
oil company in Canada. So
Okay.
I have to create something meaningful for them, right?
Oh, that's really interesting. So tell me a little bit about the transition from coming from China to Canada. What's your experience been like?
That's a lot to say.
Oh, okay.
Yeah, I've read so many articles about that, even about the Chakma thing that is going on, right? The society is totally different. In China, it's authoritarian, I would say. Let's not talk about politics so much, but in democratic society, I can see that people are more confident and less worried, and they have more freedom. They can do whatever, not whatever, but much more, what they want to do, what they like to achieve in their life. So it's it's changing me. My father can see that from my face. He told me last week that just from your face, your smile, I can see that you have changed a lot. In China, the pictures, I've compared the last day in China, in Shanghai, I took the picture with my father. I've compared the picture, and what I seem like now, it's so much different. I was depressed in China because some cultural things, it's a great transition.
So as an engineer, you're working with different tools and different inventions and trying to put stuff together and build something to improve things. That's That's like the most basic idea of engineering. But you kind of mentioned though that one of the reasons you came over to Canada was to study these like liquid coking mechanisms because they're copyrighted or they're trademarked. And I'm kind of interested that how do you guys, as engineers, since there's two of you on the mic here, try to be creative and make innovations when you have to work around trademarked or copyrighted inventions?
Yeah, I'll just go for myself personally. Like, we work a lot in teams. So, we have a lot of different experts in a lot of different fields. And it's really, when you look at each person's perspective on the team, you can usually come up with interesting ways, not necessarily around, but somehow to incorporate that inside your design. So I think that that's the more important thing. Really, it's the teamwork. We're not just one engineer, it's engineers. Like, we're always working in a team of 4+ people. So it's really to pull from that collective group knowledge and try and produce something different. I don't know, is it the same at IC4? You got a lot of people working there. You got many different types of reactors going on there.
Yeah, we got like all three dice to bat. What I want to say here is like, of course we get like trademarks or patency like that, but to work on the projects from industrial companies, you can keep up with the front line. I've met with 3 guys from Syncrude and 3 guys from ExxonMobil last year. I've learned a lot because what they showed me is like, it's really important thing. Because they have the patent, right? So they have to like develop. They cannot do just rubbish, right? it's their own project.
Okay.
Yeah.
I'm just going to jump in a second. Just to kind of go back to my bread and butter, the humanitarian side of this. You're saying that since you've been here, as a person, you're happier and you're in a better place. I'm curious as to how that's impacted your research. Do you find that you're making bigger strides here because of the way that your personal life has improved?
Yeah, of course. Like, that really matters. Because, like, for the master's program, I didn't finish that because it takes 3 years. I only spent 2 years, and when I got the offer to come to Weston, I just quit there. Kind of like fired my former supervisor. So, serious, like, it's really like that. Because, like, the living conditions, like for here, like there's much less personal conflicts. It's that depends on the culture, I think. So like if your life is easier, you can focus more on research, right?
Well, absolutely.
Yeah.
And just as a flip side to that same question, Joe, I'm going to put you on the spot here because I know that you have been to China to do research and stuff. I want to know what your impressions of it were while you were there.
Well,
Without,
I think
starting.
Yeah. Well, I think the hard part for me was I couldn't speak the language. Like, I could say basically 2 things that I started off with ni hao, which is hello, and xie, thank you. And you can get by a lot of conversations with just doing that. Like, it's almost every interaction. You buy something, ni hao, and xie. Like, I couldn't even tell you how much dollars things were. I couldn't know any of that. But, so on that side of it, it was a little bit more awkward for me. But in terms of the research, I found the teams that I was working with in China were very, very interested in just learning a little bit about me and learning a little bit about what I had to say. Because I can say that the Chinese, like the teams there, were very, very effective at what they did, but they didn't have, I would call it the imagination gap. There was a lack in imagination between a problem and a solution. They weren't able to make the jump between those 2 things. Like, is that something you've experienced, Ben? Like just having that role reversal where you're not just on your task, you're trying to invent new things or you're trying to solve different types of problems?
Yeah, in a program I attended before, it's more like doing the same thing. All the projects are like just repetition. For my supervisor. For Sinopec, the largest oil company in China, he has done like the modification for 38 delayed cokers of Sinopec. So it's like, it's just a repetition for him, but he can make a lot of money, Yeah. But like the improvement, you need like creation, right? Sometimes you need to throw crazy ideas on your students or like on yourself. Just try that, right?
Yeah, and in the little chat we had beforehand, you mentioned that the best piece of advice almost is that you can't just say no to an idea because you don't think it's going to work. Pardon me. You have to actually try it. So I was curious when I read that, what is the craziest thing you've tried as a solution to a problem since you've been at Western?
I got a tank for liquid injection. So there's the hole at the bottom, and I use a high pressure, like 100 psig, so to press the water downwards. But I don't want the gas. Like when the water is gone, there will be gas going down, right? But I don't want that. I don't want to be like immediately like the hole to be shut down. So I wasn't thinking about the idea, but like my supervisor said to me, like, why don't we try a squash ball? You know, squash ball. So I bought the squash ball from Sport Check.
Okay.
I thought it's like crazy, but you know, I have to try that. Because I don't know what the results will be. How can I say it's not going to work, right? So I tried that, and it didn't work. But at least I know that it will not work.
At least we can now definitively say that a squash ball is not the answer to that problem. I like that. That's awesome. Thank you.
Well, like, I guess my whole thing is, like, your transition between being the grad student in China to the grad student at Western, how has that affected not just your personal life and your research potential, but like what does it do to your future? Like where do you see yourself going from here?
That depends, because I've been writing a lot. So
yeah, that's actually something. That's actually how I met you, is through your writing. And I found it, for somebody that didn't speak the language firsthand, I found it very poetic in a way that I hadn't seen before in a lot of other people.
Yeah, kind of like I got the influence from my father.
Okay.
So he likes history or literature or something, and so it's kind of like the choice between engineer and be a writer. But I'm not sure I'm good enough for that. So we'll see what I can do in the future. I'm still young.
Fair enough. Fair enough.
Are these like poems about coking?
I can do that.
Out of one, many different.
Hey.
Reduce the coke.
Ooh. I like it.
I don't know. Get rid of the black.
Little jazzy to it.
Yeah,
okay, I'm okay to that. Snapping a little. Okay.
You take out the black, stay in the black.
That's dark, dude. Oh, I don't know about that.
Yeah, for sure.
Yeah, like my whole thing is like the transition from the Chinese culture to the Canadian culture. I find that a very interesting aspect of your research. And like, you know, you make the decision from going from using this old type of technology that's been done hundreds and hundreds of times, many iterations of the same kinds of things, to saying, you know what, I'm going to go across the ocean to this small university here in this quiet little town we call London, and you know, just see, you know, this new type of technology and how it's being applied. And like, I guess I'm really interested in how you're making that jump. I'd really be interested for you to share that with me.
You mean like
what it takes, what it takes to do that kind of, what kind of decisions were you making?
It's a long story. I've always wanted to go abroad to study, like maybe this. I've applied for university in the States and also in Canada. So it's like I want to, because I've been reading English, so I like the English culture, like literature, philosophy or something. And since I, you know, like I'm an engineering student, so I also want to like study something like that is more on the front line, you know, like the projects from ExxonMobil, you know, they're doing kind of, they are the biggest oil company in the world. They're doing like the wonderful job, you know. So it's a perfect choice, actually, in comparison to what I've been doing in China, right?
So what kinds of things have you experienced that you hadn't got in China, aside from, like, you know, this creativity gap? Like, what other kinds of things have you really enjoyed about your time here?
I would say freedom.
Freedom. In what sense?
Because, you know, to be honest, like Chinese people are a little bit more judgmental.
Okay.
So like when they judge you, it's kind of like a prohibition for your behavior, right? If you want to do something that seems like imaginary or crazy, you know, maybe I won't do that in China. But here, who cares? Like, you just do your own thing, right?
So maybe the pardon me, the poetry wouldn't fly so much at home, eh? And I'm just curious, where do you want to go with your research? What are you hoping for in the future? Like, where are you going to go from here?
From here, I think I would like focus on flute coking and see what we can get from how to. The main purpose is to like get more gasoline and diesel.
Mm-hmm.
That's the main purpose. So I'll investigate more to see what I can get from my research now. Because I've just been started I've just started my formal experiments after like 6-7 months of trial and error. So it's like I didn't get formal results, so I cannot like say too much about that. But I hope it will be good, you know.
So now just for all those of us that aren't engineers, because I'm sure you know what that means, but when you say the difference between trial and error and formal experimentation, just what?
Big difference, big difference.
Yeah. Like at the beginning, you have to do modification, adjustment to equipment. Like what pressure, what temperature are you going to use, something, right?
Yeah, because always on paper it's like, oh, it works, it's perfectly fine. You're like, okay, cool, let's build the thing. And then you build it, and then suddenly you got, valves are exploding, you didn't depend on, you had these seals that are just cracking and things like that, and you got to learn. I don't know about yourself, like for us, we have to learn how to do all of that ourselves. So at this point, I'm fairly confident in plumbing a house. Like, I could do that fairly confidently. But, you just never learn those things in school. It's just, you have a problem. They're not going to pay money to fix it, so you're the guy that has to fix it. So, it's this huge kind of challenge in all kinds of different ways. And then suddenly you start generating something that is actually, it's working. Okay, cool. Now let's start, right? And so that's where the formal results start coming in.
Yep, that's true.
All right, everybody. I think we've had a really good run. It sounds like we got our next show lining up to come on in. So thank you very much, Ben, for coming to talk to us.
Thanks a lot, Ben.
And this is you've been listening to Gradcast on CHRW 94.9. And check us out. We actually run a podcast every week on our off weeks, and that's all at gradcastradio.ca. And of course, one little personal note. This was Joe's last show tonight, and I want everyone in London to wish him well as he moves on to bigger and better things.
Oh, thank you so much.
Best of luck. I'm just going to say goodbye first because I don't want to start crying on the air.
Stay safe, London. That's all for this week. If you want to send us some feedback, or if you want to come on the show yourself, email us at gradcastradio@gmail.com. Be sure to hook us up on social media. On Twitter, we're at GradcastRadio, and look up Gradcast Radio also on Facebook. If you want to subscribe to the podcast is located at gradcast.podbean.com, and it's on iTunes. And while you're there, why don't you leave us a review? It really helps us out. We'll see you guys next week.